Good evening, my dear students. Okay, coming to the this lecture, we are going to study in this PPT, that is a problems on truss element, that is second problem and third problem. Okay, so in the previous lecture we studied about the problem number 1, that is a truss element that belongs to the 4 element. Okay, number of element present in that 4 elements. Okay, and 4 nodes and 8 degree of freedom. Okay, so in this we are going to study about different types of problem, that is inclined forces. Okay, if they given inclined forces means how we are going to solve such type of such problems. Okay, so look at here. Okay, so this is what the syllabus I told in the introduction class. Okay, so coming to the second problem. So here this question when they ask you around 14 to 18 mark in the examination. Okay, so here in the previous lecture we studied about the 4 element. Okay, but in this lecture we have only the 3 element. Okay, so already told you what you mean by truss. Truss is nothing but what? It is an engineering structure which is made up of a number of bars connected to a welded joints or some other help. Okay, that is nut and bolts is called as what? The truss element. Okay, look at this diagram. So it is how many elements, how many bars are present in this element. Okay, so this is one. Okay, and this is second, and this is third. Okay, so these are the number of bars which are connected to a nodes, that is called as here. Okay, 1 2 3. Okay, so now I will read the question here. Okay, problem number 2. Okay, consider the 3 bar truss shown in the below figure. Determine the nodal displacement, stress in each element, and reaction at the support. Okay, take the Young modulus for the first element, 2 into 10 to the power of 5 Newton per mm square. So here they are not mentioned E1, E2, E3. So common for all the element is the Young modulus is 2 into 10 to the power of 5. Okay, and area for first element they given for this element is equal to 1500 mm square, and A2 and A3 area which is equal to 2000 mm square. Okay, so this is the given. So you need to calculate the nodal displacement, stresses, strain. Okay, and the reaction at the each support. Okay, so this is what the 14 mark question they may ask you like this. Okay, so just to observe the diagram here. Okay, so first thing is what? How many elements present in this element you have to note down, and how many nodes are present in this element you know to understand, and how many degree of freedom will present in this given problem. Okay, so look at this is a triangle element they given. So this element consists of 3 elements. So this circle indicate element number 1. Okay, this is element number 1, element number 2, element number 3. Okay, so given the element number 1 to 2 is length is 800. If you divide this half, you can it will become what? 400. Okay, total length is 800 mm. Okay, so from node number 3 to node number 1, that is y, length is given 400. Okay, so here look at here, node number 1 is fixed and node number 2 is ruler support it is. Okay, so this means what? Here in node number 1, so completely the both the degree of freedom, that is 192, going to delete, but here ruler support means here the x direction movement takes place. Okay, this element will move along the x direction, but it will not move the vertical direction. So F4 is fixed. Okay, that is a force, that is vertical direction is force, that is Q4 is fixed, so you have to delete that also. Okay, so here 150 kilonewton is given, F6 is given. Okay, so this is about the diagram explanation. So you need to calculate with the help of this data, you need to calculate what? Element stiffness matrix for the each element. Okay, so if you want to find the element stiffness matrix for the truss element, you need what? Area will required, Young modulus is required, length of each element you required. Okay, so here length of element 1 is given, but a length of element 3 and 2 is not given, but instead of that they given what? This length and this height they given. Okay, so using Pythagoras theorem, this is the 400, this is 400, you need to calculate, that is square root of 400 square plus 400 square, you may get 5 6 something. Okay, so that is the length of second element and third element. Okay, so look at here, I am going to solve. Okay, what is the first step is what? Compare the given diagram into, you have to build a finite element model. Okay, so just to simplify this diagram, that is called as a free body diagram. Okay, so look at here, so this is the triangle element. Okay, this node number 1 is fixed, node number this one is, node number 2 is ruler support, node number is nothing is given. Okay, so here at node number 1 you are going to consider the starting point is here, so put comma length is 0 comma 0. So each node having 2 degree of freedom. Okay, since truss is belongs to the 2D element, so each node having 2 degree of freedom, one is 1, another is 2. Okay, 1 2. So Q1 Q2 are the degree of freedom at node number 2, and Q3 Q4 are the nodal degree of degree of freedom at node number 2, and Q5 Q6 are the degree of freedom at node number 3. Okay, so along the x direction you have to consider 1 3 5. In vertical you have to take the even number. Okay, 2 4 6. Okay, so here the force F6 is applying opposite. Okay, so consider F6 is given 150 kilonewton. Okay, so now the length of the first element is given 400 plus 400 is equal to 800. Okay, at node number 3 we don't know that, we need to calculate. Okay, with the Pythagoras theorem. Okay, that is 400 square root of 400 square plus 400 square, which gives the length of 2, which is similar to this. Okay, Now this is the, we are going to consider the starting point 0 comma 0, and at node number 2 what is the x distance? 800, y is 0. At node number 3 is half of this is 400, this is 400. Write down x and y is 400, 400. Okay, so after completing the FEM model, go for the step number 1, that is nodal data. So how many nodes are present in this element? 1 2 3 is there. So write down here 1 2 3. Okay, so this is the x and y. So this is the, you have to remember this table. Okay, so at x and y for the initial node number 1 we are going to taking here initial length is 0 comma 0, put here 0 comma 0. Okay, so second element coming to the node number 2, the length of x is what I am telling you, x is length of x is along the horizontal direction, y is vertical direction. Okay, so at node number 2 here, from here to here length is 800 is there, substitute 800, and y, so y distance is 0 is there. Okay, nothing is given, it is initial only, so put here 0 value. And at node number 3, come to that node number 3, so x distance exactly from here to here, x is 400, and y is from here to here is also they are given 400. Okay, so now like this you have to construct this nodal coordinate data with the help of this given simplified diagram. Okay, so coming to the second step is element connectivity table. Okay, so this is also the element connectivity table you have to construct. Okay, so how many elements are present in the given element in the given diagram? 3 elements. Okay, so that is this is element number 1 2 3. So note down here 1 2 3. Okay, if you consider element number 1, so nodes are present 1 9 2. Okay, so this is called as the initial node, this is called as final node. Okay, node number, if you suppose if you draw the separate one, so this is called as initial node, this is called as a final node. Okay, so here node number 1 is initial, node number 2 is final. So write initial node for the first element is 1 is there, you write here 1, and initial node for the second element you note on the second. Okay, coming to the second element, so second element is this, so initial node is 2 and final node is 3, initial node is 2, in final node is 3, note down here 2 and 3. And coming to the third element, so third element is there here. Okay, so initial node is 1, final node is 3. Why it is initial node is 1? Because we are started from here 0 comma 0, so hence initial node is 1 comma 3, don't write 3 comma 1. Okay, so initial node is 1, substitute here 1, final node is 3. You start from this side, not from this side, because origin is this side. Okay, so hence it is 1 comma 3. Okay, the initial node is going to consider as 1 and final node is 3. Okay, so coming to the next column, that is length of element. So first element they given 800. Okay, this length we not given. Okay, they are not given, so you need to calculate that one. Okay, that is how to calculate Pythagoras sum, or use this formula. Okay, you are going to get same answer. Okay, so square root of 400 square plus 400 square, which gives 565.68. Okay, so this also same length is where, so same as it is it will come. Okay, that is 566.68, that is the length of element. Okay, don't take 400. Okay, so 400 is the height, the length is different, this height is different. Okay, so length you need to calculate from here to here, here to here, don't consider this. Okay, so with the help of this formula, so you are going to get 565.68. Okay, so now coming to the direction cosines. Okay, direction cosines we are denoting as L and comma M. Okay, how to calculate this L and M? Okay, so already we taught you in the first problem, so that is L is equal to what? X2 minus X1 by 2, that is final node minus initial node. I wrote here formula where L is equal to X final node minus X initial node by length of element, M nothing but the Y distance. Okay, Y final minus Y initial is equal to length of element. Okay, so coming to the element 1, so we are going to talking about element number 1, we got L and 1 comma 0. How we got 1 comma 0? So look at, so for element number 1, so what is the final node? X2 minus X1, so X2 is the final node, 1 is the initial node, so X2 minus X1 by length of first element 800. So X2, these are the values. Okay, X1 value is X2 value, and X3 this is Y1 value, Y2 value, Y3. Okay, so X2 minus X1, 800 minus 0 divided by length of first element 800, which gives 1. Okay, so coming to the M, Y2 minus Y1, 0 minus 0 divided by length, so you are going to get 0. Okay, like that you have to calculate this. Okay, second element is this one, final is 3 2, so 3 X3 minus X2, X3 value is 400 minus 800 divided by 800, which gives minus 0.07. Okay, coming to the that is what M, so M is what? Y3 minus Y2, so 400 minus, that is what here second element. Okay, second element is this one, final is 3 2, 400 minus 0 by length is also 400 is there. Okay, so length is what? 566.68. okay, substitute divide means you are going to get 0.70. okay, so like that you have to calculate the direction cosines. Okay, once if you finish this, go for the next, that is element stiffness matrix. Okay, we have the element stiffness matrix for truss element is, we have this formula, that is K is equal to AE by L, L square ML M square. Okay, I already told you how to remember this formula. Okay, so once again I will tell you how to remember this formula. Means you have to remember only these 4 first. Okay, that is L square ML M square. Okay, write as it is in this side, put negative sign. Okay, so minus. Okay, these 4 quantity has write as it is this side. Okay, opposite of this, and this values you write opposite to this as it is. Okay, so that form a element stiffness matrix of truss element. Okay, you no need to by heart this. Okay, just to use logic and remember this formula. Okay, so that is K is equal to AE by L, area, Young modulus, length of element. Okay, so how to calculate this? Okay, for since in the given problem 3 elements are there, so you need to calculate the 3 elements stiffness matrix. Okay, for each element. Okay, so for element number 1, so A1, E1, L1. Okay, so substitute the area they given, Young modulus they given, length of element they given, you simplify this. Okay, so how to calculate L square? Look at here. For the first element, L is value is 1, so 1 into 1, 1 square. Okay, so ml is there, ml 0 into 1, 0. Okay, like that you have to calculate this element stiffness matrix. Okay, you simplify this, you are going to get 3.75 into 10 to the power of 5u. So that 3.75 you have to multiply it inside, so you are going to get 10 to the power of 5u, 3.75 0 minus 3.75 0. Okay, like that you have to calculate. Okay, so why are here this is very important, by noting the degree of freedom. Okay, if you consider the element number 1, okay, look at here, for element number 1, what are the degree of freedom? 1 2 3 4. Note down here, 1 2 1 2 3 4, 1 2 3 4. Okay, so after calculating the element stiffness matrix for first element, you go for similar way you calculate the element stiffness matrix for second element. Okay, so that is K2 is equal to put area, Young modulus, length of each element. Okay, again for second element is so minus 0.07 minus 0.707 is there, so square of this means you are going to get here 0.50. Okay, so like that you have to calculate this second and third element. Okay, for second element degree of freedom start from 3 4 5 6 3 4 5 6. Look at here, in the second element the degree of freedom is 3 4 5 6 3 4 5 6. Okay, so similarly you have to calculate the third element. Okay, that is K3 is equal to same, put the Young modulus, area and length. Okay, so simplify, you are going to get 10 to the power of 5, this one. Okay, so here you have to note down the degree of freedom is 1 2 5 6. Okay, for third element degree of freedom is 1 2 5 6, not 3 1 not a what 3 1 5 6. Okay, it is 1 2 5 6. Okay, look at here element number 3. Okay, so this is element number 3 means initial start from this 1 and 2 5 and 6. Okay, like that we have to note down. Okay, so once if you, and here while simplification each element the power is should be same. Okay, like that you have to simplify it. Okay, though this is 10 to the power of 5, this is 10 to the power of 5, so 10 to the power of 5. Okay, by doing this we need to you can get the simplification easy in global stiffness matrix. Okay, so since here maximum nodes are 6 is there, so put here 6 into 6. Okay, in the all the element 10 to the power of 5 common is there, so write down 10 to the power of 5. So 6 into 6 matrix you have to note down. I already told you this how to write. Okay, so this is what 1, this position, node number position for this value is 1 into 1. This 1 into 1 you check in all the 3 matrices K1 K2 K3. Okay, so if you add means you are going to get 7.28. Okay, like that second element, so 2 1 2 1 is check in all the element, you are going to get 3.53. Okay, coming to the this value node number is 3 1 3 1 you add in these matrix, you check it, so if you add means you are going to get 3 minus 3.75. Okay, like that you have to form this global stiffness matrix, you calculate this. Okay, so coming to the next global force vector. Okay, so we know the harmonic number of degree of freedom which is equal to force. Okay, so here 6 degree of freedom will be there, so 6 forces will be there. Okay, so F is equal to F1, F2, F3, F4, F5, F6. Okay, so F6 is we are going to consider this, they given 150 kilonewton, so it is acting towards the node, so consider negative sign. Okay, if this direction is this side means consider negative, upward means consider positive force. Okay, so they given kilonewton, you have to convert into what Newton. Okay, so minus 150 into 10 to the power of 3. Okay, so after that I have put substitute in equilibrium condition. Okay, that is this is the next step. Equilibrium equation for the entire truss which is given by K is equal to Q which is equal to F. Okay, so K we calculated, so substitute here value, so this don't forget to write this, this is also very important, and Q is equal to Q1 up to 6 and force value is F1 to F6. Okay, so after applying this look at the diagram. So here node number 1 and node number, in this node number 1 and node number 2 is going to fix. Okay, that is in node number 1 roller support will be there, and at node number 3 is, at node number 1 is the fix is there, so you have to delete the first column. How many degree of freedom will be there in the node number 1? So first row first column. Okay, so here is at node number 1 2 degree of freedom will be there. Okay, that is Q1 and Q2, so delete, that is also in the given diagram they given fix, so you have to delete like this. Okay, node number first row first column like this you have to delete. Okay, and coming to the second column second row. Okay, like this you have to delete. And one more at node number 2 it is ruler fix. Okay, ruler means along movement x direction takes place, and whereas in the y direction it is fixed, so Q4 is there, so 1 2 3 4 Q4 also you have to delete like this, and Q4 1 2 3 like this. Okay, so after deleting like this, so remaining what is there, 10 to the power of 5 is equal to, okay, so remaining is what, 10 to the power of 5 is equal to this what, Q3 Q5 Q6 will be there. Okay, so that you have to note down the in the next slide. Okay, so that remaining you have to note down here in the next slide, that is what this side. Okay, so after applying the boundary condition in the given problem, q1 q2 q4 which is equal to 0, so remaining is q3 q5 q6. Okay, don't write here 1 2 3. Okay, whatever it is there in the question you write as it is. Okay, q3 q5 q6. Okay, so f6 is value is they given 115 to 10 to the power 5. On simplification you are going to get q3 is equal to 0.2 and q5 is equal to 0.11 and q6 is equal to minus 0.132. Okay, so similarly you so total nodal displacement of the for the entire structure is given by, so q1 q2 q4 which is equal to 0, so remaining is you have to note down. So this is q1 value, this is q2, this is q3, this is q4, this is q5, this is qc. Okay, so this is about the displacement, okay, of the given bar element, okay, given truss element. Okay, so coming to the stress element, how to calculate stress. Okay, we have the for the formula for the first element. So 1 2 3 4 will be their displacement for first element. So E by L minus m LM. Substitute all the values, you are going to get the 50 Newton per mm square for the stress element for the first element. Similarly for the second element, degree of freedom will be changes, that is q3 q4 q5 q6. Substitute these values and multiplication, you do the multiplication, you are going to get sigma 2 is equal to 53 per, that is what, 53 Newton per mm square. Okay, for the second element. So similarly third element degree of freedom is 1 2 5 6. So 1 2 5 6 will be there. So substitute the displacement values, you are going to get stress value sigma 3 is equal to 53 Newton per mm square. Okay, like this you have to calculate the displacement and stresses for the given truss element. Okay, so coming to the reaction, same. So we have the reaction formula R is equal to kq minus f. Okay, so substitute all the values, simply you have to do the multiplication to this, you are going to get the 6 values, again you subtract, you are going to get this r1 r2 r3 r4 r5 r6 values. Okay, so like this you have to calculate the element stiffness for the given truss element for the displacement, stresses, reaction. Okay, so this problem carries around 14 to 18 marks. Okay, this is very important, just to remember in this problem is wherever nodes are fixed you are going to delete, that's it. Okay, that's it, remaining procedure is same and you have to remember the formula. Okay, so coming to the next problem, so look at here, and that in the assumptions I already told you, at the each node the degree each node in the truss element the force should be acting either tensile or compression. Okay, but not inclined. Okay, so this is similar to previous problem only, same value, same everything will be same is there. Okay, so instead of acting vertical the force is acting inclined. Okay, so for how to solve inclined problem. Okay, so here 3 elements will be there, 1 2 3. Okay, so same question, same everything same, just same problem will be there. So here only thing is you need to change is, so this inclined force you have to resolve into 2 components, one is horizontal, vertical. Okay, that is which gives the f5 and f6 values, remaining procedure is same. Okay, so node number 1 is fixed, so you have to delete first row first column, second row second column. Here also f4 you have to delete, so here you have to simplify. 3 elements are given, so this is 800, this is 400. Okay, so look at here, it is similar to the previous problem, but here at node number 3 the load is acting inclined load, so you have to resolve into 2 components, that is how to incline these 2 force. Okay, that is f5 is equal to, along the f5 you take consider cos, and vertical you have to take the sine. Okay, so f5 is equal to minus, so I told if the force direction is toward the node means consider negative, so minus 150 into 10 to the power of 3 into cos 45, and f6 is equal to minus 150 cos 10 to the power of 3 minus sin 45. Okay, so f5 f6 is given in this problem, so remaining procedure is same. Okay, so global force factor for this one is f1 f2 f3 f4 f5 f6. Okay, f5 you given, the f6 is given, so after resolving this, so vertical and horizontal. Okay, so horizontal f5, vertical is this what, f6. Okay, so after applying the boundary condition in the previous problem only, same values I got here, but only changes this one. Okay, so f5 f6 substitute the force value, simplify, you are going to get the q3 q5 q6 values. Okay, so for stress again same, so this is minus L minus m LM. So for 1 2 3 4 for the first element, second element is 2 3 4 5. Okay, for the third element is 1 2 5 6. Okay, so like that you have to calculate the element stiffness matrix for the what, for the given truss element. Okay, for the inclined force you have to resolve into 2 forces. This is very important. Okay, so this is the only you have to remember the points here. Okay, in this problem. Okay, so it is similar to that. Okay, so I hope you understand this problem for the both the problem, that is second problem and third problem. Okay, so in this problem we are going to remember is first a list of formulas, and after looking the diagram which row which column you are going to delete, that is most important. Okay, so I hope you understand this problem. Okay, thank you very much.